Hello everyone, welcome to the next session of this training. In this session we will be discussing about RFC fundamentals. We already seen what is the use of RFC function and how we can use this RFC in our business scenarios. Now let's see some more fundamentals of RFC, how this communication is going to happen. We know what is the use of gateway. We seen the gateway in our previous sessions. So gateway plays a very important role in RFC communications. The gateway can be implemented in the same SAP system as a service, and gateway also can be a separate system. You can have, if let's say you have a big systems or big landscape where you have quite a lot of SAP systems are implemented or installed in one specific location or one network, then you can have gateway server separately. You can implement gateway server. We've seen central instance, application instance, database instance. Same like that, gateway also can be installed as gateway instance, separate instance, whereas all your SAP system in that specific network will pass through the gateway. That also possible. However, each SAP instance, each SAP central service have a gateway installed into the SAP system by default. If you can see in the in this diagram, this is an SAP system where you have a gateway service already in the ABAP instance. Here also you can see one SAP system where it's only Java instance. There also you have a gateway service. So whenever RFC communicate from one system to another system, either it is ABAP or it is a gateway or it is a Java instance, or if it is a dual stack instance, the communication between one SAP system to another SAP system is through gateway. That means when you call RFC through gateway, it will call the another gateway in the second system. Okay, so gateway plays very important role in our RFC communication, through which you can also control which are all the RFC calls should pass through this specific systems. If you go more deeper into security side, there is something called seginfo and reginfo. These two files which is maintained in the SAP system, basically it controls these RFC functions where you can define which system should call in or which system should be called from there. So this is especially coming from this gateway. Okay, gateway plays a very important role in our RFC communication. So as we seen, CPIC is the protocol, that is the common program interface for communication, is the one which is used in the RFC communication. Meaning to say, the advantage using RFC is that if you are writing a ABAP program, you don't need to write or you don't need to program the function call itself to another system. That will be done by the SAP. That when you define the SM59, you create the RFC. In the ABAP, what you will do is function call function, then you will define the RFC, then you just set the parameters, and it will automatically call. Thus calling of the remote system is done by the RFC itself. And this RFC have different groups. Okay, let's go to the next presentation. Okay, you can see RFC connection groups. We have ABAP connections, HTTP connections to an external server, and internet connection and TCP/IP connection. So we have mainly 4 different type of connection. In the next one is common via ABAP driver. 4 different type of connection. If you go to SM59, we can see this very clearly. If you go to the transaction code SM59, where you can use this transaction code for creating RFCs and maintaining RFCs. Here you can see all the different groups. If you see in each group, you have different RFC connections. So if you go to bigger system, since our system is new and fresh, we do not have any connections here. The connections you can see is this ECC, it's an internal call. There is no connections at all actually. These are all default connections. So if you see in a bigger system, you will have quite a lot of RFC connections. In that case, it's quite difficult to find out which is the RFC which you are going to use. In that case, you can also use the search functionality. Okay, if you use the search functionality, let's say I want to find this IGS, something start with IGS, it's a TCP IP connection. Let's say I don't know, so I wanted to search all the RFC which start with IGS. If I say IGS star, you can find this particular RFC destinations, then simply select there, then it will take you to the particular RFC destinations. That means you can search the RFC destinations. Okay, that is quite important. So if you see here, we have different type of connections. ABAP connection, that means you are calling an ABAP system. This is the RFC connection we will be using. And we have HTTP connections. HTTP connections also very important, that you can call a HTTP server using RFC. Provided that HTTP server you are calling in, it will support RFC functionality. In most of the cases, let's say you want to call a service, HTTP service in an SAP system, it can be quite easier. Mainly we use this one for in case of, if let's assume you are a corporate company, bigger, you are managing a corporate company, bigger company, you want to do some kind of authentication to your central LDAP server with support RFC, then you can use this HTTP connection for authentication of the users who is logging into the servers. For this kind of authentication stuff, you can use HTTP connection, or any other HTTP services. You can create HTTP RFC connections. And internet connections, this is to connect to internet standard connections. And we also have TCP IP connection. This is also quite important. This TCP IP connection, the one which you will be using for non-RFC systems. Let's say you wanted to point your SAP system to a DLL file for an external system, then you can use TCP IP connection. So that here you will, what you will do is you will point to a specific program. Let's say if you see here, yeah, here what you have is you will point to a specific program ID, where you will call the specific program and try to execute. Through that you can establish the connection between SAP system and the specific application or specific program which you are calling. That is TCP IP connections, internet connection, HTTP connection. If you see here it will be different, that instead of program ID, generally what you will have is, if you say ABAP connections, let's cancel this one, take any other existing ABAP connection. You can see here host name and the system ID, so that you are logging into a different RFC system. It's an ABAP connection. This is different connection group. Let's go back. Now let's have a look into RFC types. So RFC groups and RFC types, connection group and RFC type is two different things. RFC types, basically we don't define in RFCs in SM59. Please don't confuse this one. The ABAP, TCP IP connection, these are all the different methods we can connect to a different system. RFC type is basically defined in the, when you develop your application, when you program your application. Okay, we have four different kinds of RFC types, actually 5 different kinds. One is called background RFCs, but which is not used much. First one is synchronized RFC, for communication between different system and between SAP application server and SAP GUI, the synchronized RFC is used. To establish a synchronized RFC, basically what we need is the two system which is involved in this RFC connection or synchronized RFC connection should be available all time. Let's say, for example, let's take an example of our SAP server and SAP GUI. As soon as the SAP server is down, the SAP GUI will terminate automatically. So it is very mandatory that the synchronized RFC, both the system is alive. Then the next one is asynchronous RFC. In asynchronous RFC, it's same like synchronized RFC, but the parallel processing of selected task can be done in asynchronous RFC. However, this also real-time communication, meaning to say both the systems should be available in order to establish a connection. Same like synchronous RFC, but in asynchronous RFC that you can do parallel processing. That's the main difference here. Meaning to say the process cannot be interrupted in asynchronous RFC also. That means we cannot just interrupt any process which is happening. Okay, then we will come to transactional RFC, TRFC. This is special from asynchronous RFC. Transactional RFC ensures transaction-like process. Meaning to say, when you run a transaction in SAP, you have different steps, which needs to be executed in sequence. So in the transactional RFC, what happens is that you can send information with the different unique IDs where you can execute an RFC function like a transaction. Meaning to say you can execute in sequence, or we can execute in sequence of calls, we can say. However, there is some disadvantage in TRFCs. TRFCs generally process LUWs. LUW means logical unit of work. Okay, there's each unit. So this logical unit of work, LUWs, is depending on one another. If the activity which you are processing using TRFC is quite a lot, then that can affect the performance of your systems, because TRFC can be executed in sequence, and if you put quite a lot of RFCs in the system, that can affect the calling system as well as the called system. Both can be affected. Then we have QRFC. The QRFC is basically the extension of TRFC, whereas in TRFC you can ensure the transactions are executed in the same sequence as you send it from your actual system. So it goes by the same sequence, by the queue. In transactional RFC, you can, same like it's an extension of asynchronous RFC, where you can execute in parallel. However, you are not sure whether you're going to execute in the same sequence as you sent, because of the delay or whatever, or the system is not available. You have different IDs which will be created for the TRFCs which can be executed. However, in QRFC, it will be executed in the same sequence which you have released, or same sequence which you called. Okay, that is the difference between QRFC and TRFC. And we have something called background RFC, which is BG RFC. Is basically a combination of TRFC and QRFC. Next, what we will see some resource management. This is very important for us. So what we seen that RFC can be quite sometime it can create some problem workload in the systems. So we have to be very clear what resources we are allocating to the RFC. Meaning to say, let's say you have an RFC call from an external system. The external system is trying to call or trying to process quite a lot of information. We can see it here. Let's say this is our SAP system. We have SAP GUI, it's coming to the dispatcher, and we also have message servers, or maybe some another message server coming to the dispatcher. We also have RFC logons which coming to the dispatcher. If let's assume your dispatcher is processing all the RFC calls and giving to the work process, whereas you have specific work process. You have specific number of work process to process the entire data, your SAP GUI information as well as RFC information. Let's assume the RFC information quite higher. So based on the dispatcher activities, keep allocating the work process. If the RFC is not released, and when you call the RFC function, it's a program. It's not like SAP GUI where you execute some transactions or execute some transaction by manually by entering in the keyboard. In RFC it's a program, so it will keep calling different data, so the work process will not be released. So all the work process will be occupied by the RFC, which can be a problem. So for that, how can we manage the RFC that it does not occupy the entire work process? This is very important for Basis. One simple method can be, you can have one specific application server given to all the interfaces, so it will occupy only one application server. That is one possibility. However, let's say if the call is the number of calls is quite high, the application server also can be full. In that case, you cannot also even use load balancing and stuff like this. It's quite complicated to give all resources to RFC calls. So in that cases, what we can do, that we have many parameters to manage this RFC calls. The parameter means, let's say you have a maximum dialog work process occupied by one user. You wanted to give some specific value. In that case, if the RFC call coming from one user, so as soon as we seen, when you are calling an RFC, when you are calling an external system, SAP system, you need a user and password. So let's say if the user which is coming in, I say this user can occupy maximum this amount of work process. For example, in our diagram 4 work process, then other work process cannot be occupied by this specific user. That is the best way of managing these resources, so that you can also keep some dialog work process free for SAP GUI or any other activity. So how do we do that? We have many parameters. Let's go to our system. We already know how to see the parameters. Let's go to RZ 11. So the first parameter we are going to see is rdisp/tm underscore max underscore number. As you can see, this particular parameter specifies the maximum number of users can be logged in the system simultaneously. Okay, let's go to display. Oh, there is a mistake here. It's not disk, it's disp, DISP. Okay, so if you see here, this presently it's 200. That means simultaneously it can have 200 users logged in to this particular instance. So let's go to the documentation. You can see it here. This parameter limits the maximum number of users per instance. The dispatcher creates information about the connected users in the structure of TRIM ADM. Okay, there is a structure, internal structure, which stores this information, how many users logged in at the moment with parallel. Based on that, it will limit the total number of users which can be logged in into the system simultaneously. RFC user also counted towards this total. That means it can be an RFC user or a dialog user. Same like what we have seen in our diagram. It can be a dialog user or using SAP GUI, or it can be an RFC user. Okay, so the total number of users who can log in to the specific instance is specified here. Now you may think, now we still not come to the actual resource allocation. We are talking about total dialog and as well as RFCs. Now we will come to the next parameters. Our next parameter is rdisp, then it is RFC underscore max underscore login. Okay, as you can see from the name itself, this describes the maximum allocation, the quota of number of users logged into SAP system, value extended. Okay, it does not describe what kind of user it is. This RSP disk slash RFC max login specify the maximum number of RFC users can log into this specific instance. So you have the first parameter what we have seen is RFC plus dialog, and the second parameter we are talking about is only RFC. And here you can see the above absolute number login SAP system is specified by the parameter, the first one what we had seen, tm underscore max numbers. So the tm underscore max number specify dialog plus RFC, whereas the next parameter we will limit the number of RFC to the lesser number than the one which we have seen. You can see the default value here is 990. The first value which we have seen is 200. So we reduce this number. So you have, for example, in our case, in our system, we have 290. So 110 users is reserved for your dialog instance or for SAP GUI, we can say. Okay, this is a way we can limit the number of RFC calls or number of RFC users coming into our system. Then you will have one more question. Let's say you have multiple RFCs, let's say 50-60 RFC connections. Possible, yeah? It is possible that you will have so many RFC users, because in a bigger system you keep interfacing or keep building different system you want to call from different system, and you will create different RFC connections and RFC users. So in that case, let's say you have multiple RFC connections, then one RFC is trying to execute lot of jobs, whereas other RFCs is not able to log into the systems because of these parameters, because we limited that. Okay. In that case, what we will do, we have another parameter which is RFC max won't login. Okay, this describes by a specific RFC users how many parallel logins you can do. That is RFC won't login. So we have covered almost all the scenarios which we want to specify based on our scenarios. Okay, we can see here it is 25. So if we have 90 in our previous ones, that is the maximum RFC logons available for one user can occupy maximum 25. So at a given point, one specific RFC is creating a lot of parallel process, maximum 25 logins they can have. But we have total 90 logins which is only for RFC, where you have quite a lot of logins which is free for RFC. This is numbers are only an example, so you can manipulate these numbers based on your system capacity, also based on your number of interfaces what we have. Like this, we have many other parameters which is related to RFC. If you see RFC, for example, max queue. Okay, this what it describes is the request queue, dispatcher quota for dispatcher request queue. How many request queue you can have on the dispatcher. Okay, so that from dispatcher itself you can start limiting. This again depends on the dispatcher element per queue. The total number of you will specify in this parameters, then you will define this will be for all, then you will limit the RFC only RFC queue to a lower number, then you can filter it from the dispatcher itself. So the dispatcher is not loaded with the RFC calls. Okay, that is the idea behind that. Like this, you can manage the resources of RFC connections. Now you may have another question in your mind. So far what we have seen is about the users. What about the work process? So we know we have number of work process, for example, or disk this WP underscore no number of dialog, which we have seen in our previous sessions. This describes the total number of dialog work process what we have. Can we limit that? Can we limit based on the work process? Still possible. We have another parameters. For example, we have right now 10 work process in total. Let's say if we have another parameter called our disk RFC underscore minimum wait dialog or process. If we go to this parameter, if you say document, number of dialog work process that should remain free for other users. That means this is RFC minimum wait dialog work process. So if you are calling this particular system which has 10 dialog work process, at least one minimum work process should be kept reserved for other users and are therefore not available for RFC requests. So whenever the dialog users logs in the total number of work process, whatever it may be, this number of work process is not occupied by RFC. In our case, 10 work process, one work process is never occupied by dialog work process. You can see it here. If no more dialog work process available for RFC request, no further resources are returned to the caller, since the server should be processed for overloading, so that the calling system may get a message and the server is overloaded that you cannot call anymore, because one dialog work process we reserved for our normal users. The above number dialog work process specified by the parameter rdisk slash work process number of WP underscore no underscore dialog. So here we will specify total number of dialog work process. Here we will specify the number of work process should be reserved from RFC. This is little bit tricky here. Like this, we have parameters which can help you to tune the RFC calls from SAP systems. Let's see some other transaction codes which is also relevant for us for this RFC resource management. For example, the transaction code is to check the server resource, that is SARFC. This gives you the resource available in the specific system. Okay, this resources can be changed. For example, if you select this and go to the detail, just say double click and say, here you can see the resources. The activated is 1, that means whether it is resources active or not active. Yes, maximum number of requests in queue is 5. The maximum number of logon users that we seen from our parameters, which is 90. This maximum number of separate logon per user, that is 25. Maximum number of used for work process is 75. Maximum number of free work process is 1. These are all the parameters which we have seen. Okay, and these values can be changed from here as well. We can simply change this value from here. Okay, this is very useful transaction code in terms of RFCs, but in a larger system, in a good way of doing analysis is that don't change these parameters until unless you are quite sure about that, because this can have another implication, another impact on different systems or different applications. So we have to make sure before you make any changes. And we know SM59, F59 to create RFC connections, and we have SM58 to monitor the transactional RFC. Let's say SM58. Go to SM58. Here you can see the transactional RFCs in the systems, and you can also filter by user. Let's say put for all user for today's transactional RFCs. But this is a fresh system, as I said, there is no interface running, so we don't have anything. We can monitor it like that. If any transactional RFC is like pending because of some issues, then we can delete that particular request from here. You can see the delete button, you can delete it if it is lying there for quite long time. Then we have another, for QRFC we have two transaction codes. We can also monitor inbound as well as the outbound QRFCs. Let's say /n SM-Q1. SM-Q1 is for outbound RFC. What are all the QRFC which is going out? We don't have anything. You can also see what is waiting in the queue. Okay, meaning to say you created a QRFC to an outbound system, but whether it is reached or is still sitting in the queue, until unless it reached there, it will be still lying in your queue. So if it is lying in your queue, that means the destination server, it's not available, or it is overloaded or some reason. Then you can go and find out what is the reason behind that, and you can reprocess it. Otherwise we can delete this queue if it is not necessary, so that the next queue can process it. Okay, the next request which is in the queue can be processed. So this is for outbound queue. Then for inbound queue it is SM-Q2. This is for inbound queue, what is coming in. This also important to monitor. In general, if it's your system have a lot of QRFC and TRFC being processed, then it will be also good idea that you monitor this SM-Q1 and SM-Q2 every day, because this can have a bigger impact. If these RFCs are not processed for long time, then you have a business transaction which is pending for long time, which is not happening. Maybe it's a production order which is coming from an outside system to your system, or some critical informations which is coming but it's not been processed. So it's important that you monitor this quite often. And we can also monitor the background RFC, which is the combination of TRFC and QRFC. That is, the transaction code is SBGR FBG G RFC mon. Yes, background RFC monitoring. Here you can monitor almost everything. You have a lot of selection criteria by user, by inbound destinations. You can filter it, maximum number of displays also you can have it, so that it's quite easy to monitor this one, and easy to see in one view that how many processes are pending. Okay, and so we can use this as well to monitor it. And one more thing we need to see is that we've seen so far the parameters specific to instances. So in the initially we said we can create groups, for RFCs. It's not like your logon group. Logon group is different. And if you go to SM-59, here if you go to extras, RFC groups. Okay, here you can create a logon group for RFC. Okay, we seen so far what we seen SMLG. LG, that is the logon group for dialog users. The one which we are going to see is SM-59. Here you have the logon group. This is logon group for RFCs. Okay, this you can specify. Let's say if you go to 59, when you are, let's assume that you are going to call a different system, here you can specify the group, whether it is a single system or a logon group. Okay, you can specify it here. If you say load balancing, then instead of target group, it will target host, you can specify the group. Okay, and that group, this also have a separate transaction. I think it's RZ 12, or we can go and check it here. Yeah, this RZ 12. If you go to RZ 12, you can directly come to this specific screen. Russian. Yeah, RZ 12. Okay, create RFC server group maintenance. Okay, this is also very useful. Let's say you want to have a specific group of servers instead of one instance, you want to give a group of servers only for RFC, then that is also possible. And one more useful thing will be, let's say at a point in time you want to find out what are all the RFC parameters you have in your SAP systems. So best way to see is SC38. We know the program RS param. Go to RS param and execute. Display. Now if you go to the parameter, always start with RDISP, yeah, and with RFC. This is RDISP. Here you can see RDISP, RFC check, RFC maximum, common entries, login, won't login, used, all the parameters related to RFC is here. So RZ param is the best way to see what is the active parameters which we have in the server. As we see in our previous sessions, if you go and check in the RZ11 or on RZ10 profile parameters, you will not find all these values because these are all default values which is already defined in the kernel. So best way to see is run this RZ param, then it will show you the entire parameters which is available in the server. That's the best way to see it. Or as we've seen, we can also use the SA RFC, where the same RFC parameters, basically these values are coming from this RFC parameters. SA RFC. Okay, these values are anyway coming from the RFC parameters. This is also one way to see. Otherwise RZ param. This RZ param also have a transaction code where you can limit by the parameters using wildcards, because in RZ param it runs for the entire system landscape, the entire systems. So if you use the transaction code RSPF RSPF this is the transaction code. You run this transaction code, then you will get a option where we can specify RDISP/RFC star. If we specify it like this, then you can see only the parameter which is starting with RDISP/RFC. Okay, this is also quite useful transaction code because this helps you to limit. Otherwise in the RS param you will get quite a lot of entries, then you need to search that. That also a very good way, and this also a good better way. In general we don't go by transactions because in general as a basis administration you will have authorization to run the program, so that program is used for quite long time, so people use that quite often, and this also quite useful transactions. So let's go back to our presentation. Okay, with this we are coming to the end of this session. Thank you very much for listening. I will see you in the next session. Bye bye.